Okay, hello everyone. So this is the video for explaining the module B of project 1. I have uploaded on the I have actually created an assignment under project 1 module B. You are given a description of the project, module B of the project. You can simply download this file, and then you are provided 5 different files. So you need to read them. These are skeleton files. They are not complete. And when you will read the description, you will understand how to complete them. So I just want to give you here a visual understanding of what we are supposed to do in this lab. So for that, I have prepared a presentation. So basically what we need to do is this, to say that we have the main process, which I'm here naming as process A. So when process A executes, it is supposed to create a shared memory area. Note that we are supposed to do this lab in Linux or Ubuntu. So there you can use this system called shared memory get to create a shared memory area in the kernel space. You can Google to get more detail about parameters of this system call and what value is returned. So when process A makes a shared memory get, an area will be created in the kernel. Let's say the area which is created is named as shared memory region 1 or SMR1. And let's say then after that, and this area will be used to hold a matrix. Let's say a matrix of four rows, R0, R1, R2, and R3, right? And but at this time, process A cannot yet access this array or matrix. So it first need to make another system called shared memory attach, and then give the name of the memory area. And when it completes successfully, then process A can now read and write this shared memory area, right? Then the process A also creates another shared memory area, which we are naming as shared memory region 2. Uh, uh, and it is also created in the kernel space. And then when a shared memory attach SMR2 is executed, it also becomes read and writable for the process A address space. After that, the main process, what does it do? For example, in this case, we are creating only two child processes, but in the project, you need to create from 1 to 4 child processes. So I'm keeping this example simple, where we are creating only the main process creating only two child processes. So for that, it first invokes a fork, and as a result, another process is created, process B, which becomes the child of the process A. So in process B actually initially have the same address space, a distinct but duplicate address space of the process A, but then it executes the execute LP system call, which actually is used to load a new binary in the address space of the process B, and that will be the binary of the chart process.c, which then this file is also provided to you, but again it is a skeleton, you need to complete it. That's why now the address space of B will be different from address space of A. And then when process B executes, which basically means it runs the binary of child process.c, then it also executes shared memory attach SMR1 and shared memory attach SMR2, which means that these two regions, this region and the shared memory region 2, both of them become also read and writable for the process A. After that, for process B. After that, what does the process B do? That it operates on the rows which are assigned to it, and who assigned it? Process A assigns it, right? So you need to go and learn how we can do that, right? So actually, what you can do that when you can pass the parameter to execute LP. So when you pass the parameters, you are actually when you will study the help of execute LP, you will understand. So you can pass the parameters, and among those parameters are the starting row and end row of this matrix, which is placed in the shared memory region 1. For example, let's say the starting row is R0 and ending row is R1, right? So then what does the process B will do? It will add all the elements in these two rows and put the result of their addition in shared memory region 2 at index 0. And this index is also will be passed to process B as a parameter of execute LP, right? Same then goes for another process. So process A creates another process, for, let's say process C. Initially, its address space is distinct, but duplicate of process A. But then again, process C execute ELP, execute CLP, and loads the binary of child process start C, where again it attaches these two regions, shared memory region 1 and shared memory region 2, so they become readable and writable for the process C. And then just like process B, it is also given the an index of the starting row, index of the end row, and the index of the shared memory region 2, where it needs to store its partial sum. So for example, let's say its starting row is R2 and R3, so it sums all the elements of these two rows and put the result in the shared memory region at index 1, right? So, and then the final thing which is not shown here is that when all these children processes, that let's say in this example we have only two, so when all the children processes are done with calculating the partial sum of the rows, then child process actually needs to wait for them to complete. So once they are completed, then not child process, the parent process, the process A needs to wait for process B and C to complete, and once they are completed and they have calculated the partial sum, then process A, like let's say the partial sum here is X and the partial sum here is Y. So once B and C are done with that, then A will go ahead and calculate the total sum by summing together X and Y, which will be X plus Y, right? And then get the result. So this is what you need to do in this project. And if you have any questions, please let me know. You can send me an email.